Hello everyone. Good morning, good afternoon, good evening. Today we are going to learn about VPC enhancement. So let me enable the pen. Now in the VPC enhancement, there are various advanced concepts that are used to enhance the VPC system. Following are the some VPC enhancement that we are going to study one by one. So one is the peer gateway exclude VLAN, VPC ARP synchronization, delay restore, VPC Graceful, check, auto recovery, orphan port suspended. So these are some VPC enhancement that we do inside a VPC. So let's learn about the VPC peer gateway. So as we know that if we are configuring a HSRP or a VRRP in a VPC, both Nexus switches are able to route a packet to HSRP virtual MAC address, right? And all upstream switches will be traffic will be load balanced through VPC port channel in access switches, and access switches sends the traffic to HSRP virtual MAC address of SVI for routing. Now, but this is the ideal scenario where you have a server, so you have a different type of endpoints connected to it. But in some cases where we have a NAS server, right? So those server they have a particular teaming technique, right? Due to which they don't send any ARP request to discover gateway MAC address of HSRP. Rather, they use the MAC address received on the original request to build its response, and NAT server reply to client request, and these reply will be directed to SVI MAC addresses, not to the HSRP VMAC addresses. So I mean, if you let's see with the help of one example or one scenario. So first thing is that this is your NAS server, right? The NAS server sends an IP packet for a destination MAC, right? So this is your destination is here, one server is there, and whose destination MAC address is 0012 and XYZ. Now this NAS packet wants to talk to this destination server. Now before going to it, it will send a packet to the, because it is a NAS server, so it will send a packet to the SVI MAC addresses. So what it does, it will send a packet to the SVI MAC addresses. Now once the traffic reaches to the switch 4, what it will do, because it is a port channel, right, and this has to send a packet to the SVI MAC address of VLAN 5. So what it will do, because of the port channel, let's suppose using the port channel load balancing algorithm, it selected this path. So when a traffic receives here, the N7K2 will see that this MAC addresses is the virtual, this is the SVI MAC address which is present in the primary switch or N7K1 switch. So what it will do, it will send a traffic to here. Now once the traffic reaches here, because the traffic has crossed the peer link, right, and CFS is already working, and CFS has shared the VPC member port status information to both of the peer switches, the traffic, the N7K1 will not be able to send a traffic to the destination because of the loop avoidance system. So there will be a significant packet drop where NAS server is not able to send a traffic to its destination server. Why? Because it is using the burn-in MAC address of VLAN 5, which is there in the N7K1, but because of the port channel load balancing algorithm, it has selected a port towards N7K2. It will send a packet to N7K2. N7K2 will see the destination MAC address. It finds that okay, this SVI MAC address is available via port peer link. It will send a traffic to the peer link. N7K1 will receive the that traffic, but it will not able to send a packet to the port channel 2 because of the VPC load avoidance method. So in that case, there will be a significant drop. Now, how to solve this problem? So this issue can be solved, by configuring a peer gateway command. So we use the peer gateway command in a VPC domain. Now, if the both VPC peer switch is configured with this command, each of them will be able to route this packet. Why? Because as soon as we configure a VPC peer command, the virtual MAC address of the burn-in MAC address of SVI5, which is N7K2, will be shared to N7K1, and the burn-in MAC address of VLAN 5, which is there on N7K1, will be shared here. Now, if a NAS server is sending a traffic, the switch receives it. It uses the hash algorithm and it selects up this path, right? Once the traffic reaches here, the destination is already here. Now from here, this switch will be able to route a packet to switch 3. So this is how a peer gateway command works. Now let's talk about the VPC ARP synchronization. So this feature is used when a peer link fails, due to which SVI and member port on a secondary switch goes down. So let's suppose if you have a there is some event occurs and this peer link goes down. So what will happen? On the secondary switch, your SVI will go down. On the secondary switch, your member port will go down, right? And all the traffic will route via primary. So in that case, what will happen? All the new traffic will be routed via primary switch, and there will be a huge ARP table entry, right, at a primary. But because of the peer link goes down and the CFS is not working, it will not be able to synchronize this ARP table. So there will be a huge ARP table entry mismatch. Now, as soon as VPC peer link is recovers, because of the large ARP table, it will take time to synchronize the ARP table between peer devices. So what we will do, we configure a IP ARP synchronize command, IP ARP command under VPC domain, right? As soon as we do it, and when we configure the ARP synchronization on the VPC, and when a peer link fails and it recovers, then VPC ARP synchronization feature perform the bulk ARP synchronization over a CFS from a primary to secondary switch, right? So as soon as my peer link get enabled due to ARP synchronization feature, bulk transfer a synchronization of ARP table happens between a primary and secondary switch. So my both switch control plane comes into synchronization state. Now let's see what is a VPC delay restore. So after a VPC devices reloads and comes up, the routing protocol needs takes time to converge. So let's suppose I have a router here, right? I have some EIGRP OSPF working, and my both switches go down. So my all EIGRP OSPF process will go down here. Now once it come up, what will happen? The layer 3 protocol takes time to reconverge rather than my VPC system, right? So let's suppose my both primary and secondary goes down, right? Or it went down. After some time it comes up and EIGRP is working or OSPF is working. It will take time to it will take time to restart its processes. It will take time to form the adjacency, neighborship table, neighbor table, and then a routing table. But before that, my VPC will come up and all my server will start sending a traffic, and all my traffic will be accumulated to the Nexus 7K1 and 7K2. But because my layer 3 has not converged up, it is not up, my routing table is not coming up, because layer 3 convergence take time, all traffic will go down, right? So to avoid this black hole, VPC delay restore feature is configured. So what it does, VPC delay restore feature delays the VPC leg bring up on the recovering VPC peer device. VPC delay restore allows first layer 3 routing protocol to converge before any traffic on a VPC leg. So once you configure a VPC delay restore, right? What it does, it will delay the the VPC convergence till the time my layer 3 is up. So once the layer 3 will up, then only my VPC convergence will happen. And then once my VPC ports are up, my server is sending a traffic. I have a layer 3 path available. I will send a traffic to my router. So this is, this feature is enabled, by default with the VPC restoration default timer of 30 seconds. And this timer can be tuned according to, according to our specific layer 3 convergence baseline from 1 second to 3600 seconds. Okay. Now we'll see the auto recovery. So let's, understand this, by event wide. So let's suppose at event 1 happens. Suppose my peer link goes down and the keep live link is up. So my peer link goes down, but my peer link is up. So what will happen? My gateway will go down and my member port will go down. So all my traffic will be going via primary. So this is my event 1. Okay. Now let's suppose as soon as this happens, after some time, another event happened and my primary switch went down. So second event is my primary switch went down. So what will happen? Once my primary switch will went down, all its connected VPC member port will go down. Because my peer link went down, all my secondary switch member port and SVI is down. So what will happen if any traffic is coming from access switches? It will be dropped because my peer link, my primary switch is down, and because of my peer link goes down, my secondary switch gateway and member port is down. So how to avoid this, black hole? So in order to avoid this black hole, we configure auto recovery command, right? So VPC auto recovery for the purpose of previous case is not enabled by default. Activate the VPC auto recovery by using this command. So we will configure a VPC auto recovery by this command. Now what will happen? If auto recovery command is configured and if if we are in a second state where my primary switch is down, my peer link is down, right? My primary VPC member port is down. And if we have a VPC, auto recovery command configured, so what it will do, it will on a secondary switch, it will enable all SVI and it will open all the VPC member port which was down earlier, right? So that one of my path is available. So all traffic will move via secondary switch. Okay. Now let's see, how the VPC orphan port suspended command work. So orphan port, VPC orphan port suspended feature was developed for a single attached devices to a VPC domain and optionally working in an active standby mode. I mean, for the firewall or load balancer instance, right? So once your device is singly attached, just like, the below figure, this is your singly attached device or it is working as an active standby, we use the orphan port suspended. Now, how it works? So whenever a VPC peer link goes down, right? So what will happen? My SVIs here, my member port all goes down, right? But because we have configured a VPC orphan port suspended, because we have not configured it, it doesn't shut down VPC orphan ports, right? Now with the VPC orphan port suspended configuration, my orphan port also shut down along with the VPC member port when a peer link goes down. So as soon as we configure a VPC orphan port suspended, if my peer link goes down, along with my second SVI on a secondary switch, along with my all the VPC member port on a secondary switch, this link also goes down, right? Now when a VPC peer link restored, because we have configured a VPC orphan port on a secondary VPC peer device, or this port is brought up along with the VPC member port. Okay. So thank you for watching the VPC enhancement. Thank you very much. Take care. Bye bye.